I hope you're enjoying Codemotion so far. Or COD emotion. I hope I'm not the only one who was reading it this way the entire time. All right, so just a brief recap on GraphQL for those not in the know so that we're all on the same page. So GraphQL is primarily a data description and query language. Oops, sorry. I don't know why that happened. So it gives a common language to the client and the server to describe data and to query that data. So, I don't know, my thing is not working. It defines a type system. So all the data coming in and out of your service is formally typed. In this respect, it is similar to WSDL or SOAP. So you can think of that when you're thinking of types, but don't think of it too much because nobody deserves that. It's an open source specification, and thanks Facebook for that, but there are implementations in various languages. Reference implementation is in JS, but everything has an implementation these days. And in this context, when I say implementation, I mean a server-side runtime for executing queries. So it doesn't matter what your application is written in, you'll probably very likely be able to run GraphQL. It's a common misconception for some reason that it's related to graph databases or for languages for querying those, but it's not. So it has nothing to do with Cypher or Gremlin or similar languages that are database specific. And it is absolutely storage and language independent, so it doesn't really matter where your data lives. It doesn't matter what language your application is in. It is like REST in this regard, so the closest thing to approximate it with is REST. It's a way for the client to get stuff from the server. More importantly, why would you want GraphQL in your stack? Well, it gives us some very sweet promises. Namely, it gives us a way to describe data formally, so similar to what I just said. So you won't need Swagger or JSON schema published in addition with your service because it will be self-descripting. And this is in the simplest example how it looks like. So here, like all examples in GraphQL, it is Star Wars themed. I don't know why that's a thing, but that's how it works. So this query gives us a character that is a hero of a Star Wars episode. So we ask for, you give it episode number, and it tells us which character is the hero of it. And you can already see some typing going on here. So integer being the input and character type being the output. Where character is defined like this, so it's a type on its own, it's an object type, it has name, it has friends, and it has a home world. Well, friends are also characters, so it's a recursive definition, so that's allowed. And then finally, the home world, which is a planet, is just defined like this. It's a simple object with a name and type. The second thing that it gives us is a promise that the client will no longer have to ever underfetch or overfetch. The client will always be able to fetch only and exactly the data that it needs and nothing else. So for example, here we need a hero of episode 4, and we care about the name and the home world, and then name and type of that. We don't care about friends, for example, so we're not fetching that. And the sweetest thing is the results are always predictable, and they're guaranteed to always have the exact same structure like the query itself. So here it is. So we asked for name, home world, and then inside name and type, and that's exactly what we get. So same structure in the query and in the result. So this way of structuring data, this way of thinking gives rise to this arguably very clean architecture that can be contrasted with what we currently normally do. So normally, you would have a client talking to multiple RESTful endpoints, where each one of those would potentially talk to different storages, depending on what it needs to do. It maybe needs to query different things, and then it merges the results, all of that, and then sends it back to the client. And it doesn't matter what the client wants, because either case, it's going to query everything, merge everything, and send it to client, because it knows how to send only this one thing. With GraphQL, it's vastly different. So the client will communicate with only a single endpoint. That's the GraphQL runtime, so single endpoint. Internally, everything that the client wanted, so every single field, will be resolved by a single resolver function, which normally is a very small thing. It needs to fetch just one single value of one single field. That's all it does. So it will normally only talk to one storage. And it means that if the client didn't ask for some field, we won't need to go to the storage to fetch that field, because if we don't need it, we don't fetch it. And then everything gets merged back by the runtime and returned to the client in the way that you saw. So So let's see how to do this in Java. So this is all like GraphQL 101. You maybe already seen it. But let's see how we do this in a normal Java application. So here we define a type. Type address, it's a simple object type. It has a street name, which is a string, and it has a house number, which is an integer here, just for demonstration purpose. Then we have a person type, which now uses this address type that we just defined. So this is the address type that we define here. In fact, a person will have a list of addresses, and this is how we fetch addresses. So this is the resolver function for the addresses field. So it will go to some database and then grab it, grab the addresses for this client in some way. And then it also has like a name, which is just a string, nothing special. And finally, we define a query. So this is how we would define a query. So as I said, we would have query name, and it takes an argument, which is name and string. So it's people by name. So it will fetch people by name. So it accepts string representing the name, and it returns a list of persons. So we saw the definition of person, and this is the resolver for it. So it will delegate to some service to resolve the value for this. Now this is the Java types behind this. So we have our person type, and again it has getters and setters. Nothing special. This is just a POJO. It has name and addresses, just like we said in GraphQL. Address itself is also just a POJO. It has a street name and house number, like we said. And then finally, the person service itself. So this person corresponds to this, and then this function corresponds to this. This is basically what's being called to resolve this. So this is everything in one place. And as you can see, it's kind of not nice. There's a lot of duplication. We had to say twice for every single type definition. 2 times we had to say that people have addresses and that they have names, and that addresses have numbers and street names and so on. Which also means, oh, I don't know, something with my clicker is going wrong. Okay. So, I am totally not where I should be. I'm here. So, that also means that changing anything, like adding a field anywhere, means we need to change it in 2 places. We need to change it in the schema, we need to change it in Java layer itself. And this is, of course, terrible, so we don't want to do that. So what we can do about it is dynamically generate schemas, because we already have the typing information in Java. It's already a typed language. We already know everything. We know that persons have addresses and names and whatnot, so we don't need to do this. So this will eliminate duplication, but it's not really a solution unless it allows us to follow best practices of the language that we are in. So we still like our stateless services, and we still like our nice and simple POJOs to model our data, so we need to be able to keep doing this. Additionally, it needs to be adaptable, because you're not going to always be working on a greenfield project. This has to work with existing code. And we don't want to be, to have to write a lot of glue code or anything in order to use it, because then we're kind of back in the realm of repeating stuff. So Speaker is the library that we developed that is trying to resolve exactly these issues. So it's trying to tick all the checkboxes that I just mentioned. So the way it works, so again, you have your person service. So this is presumably something you already have in your application. So it's a service that just stateless service modeling your business logic, doing something. In this case, finding people by name. So it takes a name, it returns a list of persons, and it does that by querying some database or something. So how do you expose this via GraphQL now? Well, it turns out you can just add an annotation and be done. So even the annotation is optional completely, but because it's a very explicit, very obvious way, I'll just use that for the examples. So this is all you would need to do to say that you want find by name method to be exposed over GraphQL. Then in your person object itself, again, same logic. All the fields you want exposed, you could annotate them. Again, annotation is optional. I'm using them just to illustrate it more clearly. So the things you want exposed, you can annotate them. And then to wire the whole thing together and expose it over web and do whatever you need to, you would either wire this, inject it with Spring or whatever, however you do your, or you can just create it like I'm doing here, just instantiate your service, create a schema generator, register the service that you want, so here, the person service, and done. It will generate the schema for you, and from here you can instantiate the GraphQL runtime. So this is the object that you want to keep on forever, basically for the lifetime of your application. And then you fire queries against this. So here's a query that would trigger this method. Sorry, yeah, the find people by name method. So it takes first name, let's say John, and then we want first name and last name back. And then you would just fire this, execute this query against this runtime object that you created. So this object you keep forever. So it's usually, you would usually keep it in some controller or a servlet or whatever you have exposing to the web. And this is it. So basically, these lines are the entire thing you need to expose your existing Java service over GraphQL. So let's see some more interesting queries. You only saw something ridiculously simple. So let's say we have something like this. Still simple. So we have a query that's asking for a person's Twitter profile. It takes the entire person object, so a complex input type, and it uses some Twitter API, something to fetch this. So let's say we have that. And then we have what we already had, like the find people by name that you already saw. So those are fine. So how do you trigger these with via query? So you have this Twitter profile query. It gives the entire person object with first name, last name, and it wants a Twitter handle and it wants number of tweets back. So this is the query for that. For the other thing, you saw the query. So people by name, first name John. So it gets this. But now the graph aspect of it. Let's say you ask for all the Johns, and there's 100 Johns, and now you want the Twitter profiles for all the 100 Johns. So how would you do that? You fire this query, and then 100 times you fire another query, and then do 100 round trips. So that's exactly what you shouldn't be doing in GraphQL, right? So these need to somehow be connected to form an actual graph that you can go into. So ideally, we would want this. We want to be able to say we want people by name, we want their Twitter profile, and we want the number of tweets inside. So this is what we're going for. So how to get there? Turns out, crazy simple. You just add a additional, so this is the new annotation. So you just mark the person as the context, and that's it. What this means is that this Twitter profile query, so it's being executed in the context of the person, which means that it will be embeddable inside anything that returns a person. So here, this returns, well, a list of persons, but same thing. So this is returning a list, then this automatically means that it can be embedded, and embedded it is. So this is the graph aspect of it. Now you have things wired together in a relationship coherently. Show, demo time. So I'll do a very super simple Spring MVC demo of how you can get this to run. So, so here's my IntelliJ. So right here, what you can see is a simple, this is just a standard Spring controller, nothing special. We auto-wire a bunch of services like we would normally do in any Spring application. So a bunch of Spring beans, they're still normal stateless beans with your usual logic. And then here, you basically, as I showed you, so you instantiate the generator, register all these services that you want exposed. Here I'm also explicitly saying I want to use Jackson for mapping values. You could use something else or nothing at all. It has a default, of course. So, and that's it. I generate the schema. And then later on, a single entry point. So this is the single entry point that I was talking about. It takes the query from the request. So it grabs the query and it executes the query directly and returns execution result. So this is it. This is the entire thing that is exposing it over web. And then inside of that, we have, for example, one of the services that I'm exposing is this vendor service. It's, usual Spring stuff. So we have a mutation. Mutation is like a query, but it mutates stuff, not just asking for stuff. So we have a mutation here that creates a vendor, and then another one that gets a vendor by name, for example, here. So let me start the application and then restart the application. Just give it a second. It is Java after all. Okay. So this is GraphQL. This is a tool that is shipped by Facebook themselves. It's just for it can query arbitrary GraphQL endpoints. And the nice thing is, as I said, the coolest part is that everything is typed. So it knows what you can ask for. It can already auto-complete queries. It knows everything that's available on the server. There's no, any swagger or anything describing this. It's just doing it by itself. So here, for example, I can already see what queries I have available. So I have vendor by ID. I have vendor by name, and I don't know, these things. If I want to see available mutations, I see there's a create vendor mutation. And if I start even typing here, sorry, I don't really see my own thing, but you see it cannot autocomplete because it knows the only available thing here is ID. So it even knows how to complete this. So let's say I want to create a vendor. Okay. Oh, because I already have this vendor created. Doesn't matter. I'll just go and do a different thing. I'll just fetch a vendor by ID or something. All right. Okay, I have no idea what's going on. Somehow it's failing now. Oh well, sorry for that. That should be working. Let me see. If I can get it to... The cool thing is I tested this 2 minutes ago and it was working. Of course. Oh well. Imagine it was working. So, oh yeah. So yeah, that was all just to show you basically how to map your Java to GraphQL. But the meat of what I wanted to talk to you about is actually the problem. So the less obvious aspects, as the title said. So something you should probably know before you start developing on this tech. So as I said, the client is now in charge. That's the purpose of GraphQL. It puts client in charge of what it needs. So what if the client is malicious? So problem here is that the query itself can be arbitrarily complex. The size of the result can be arbitrarily big. So it can ask for something that will eat the entire server memory, or it will consume so much that it chokes everything else, for example. So what we can do about it? Well, there's a couple of things in the industry that's already being used. One being that we can just analyze the query after it's parsed. So we parse it into the abstract syntax tree, so we got a whole tree of what's selected and what's not. And then what we can do is assign complexity score to each field. And it can be it's normally done dynamically, so that it's using the input parameters in the evaluation. So let's say in our person by name, let's say we asked for 20 people. So we can say the complexity of that field is 20 times something, child score, for example. So it will be analyzed dynamically, and then for each field that we fetch, we sum up the calculation, we sum up the complexity, and then if that breaks some threshold somewhere, then we simply don't run that query. So this is one way to protect, and this is probably the most advanced way of the commonly used ones. The next one is a simpler one. We can just limit the depth. We can simply analyze the query for depth and say, if a threshold is broken, don't run it, so you can only go like 10 levels deep or something and then stop. So, oh God. And another one, just limit execution time. So you run the query in a thread. If it takes more time than it should, kill the thread, be done with it. And then finally, you can just whitelist the query. So of course, that only works if you know all your clients. So if the clients are known ahead of time, you know what queries they're going to run, you can just whitelist them. You can even, then the client doesn't even have to send the entire query. It can just send the ID or something. But this, of course, yeah, makes sense only in the case that you know everything ahead of time. All the clients are known. So that's probably something that's rarely used. The even more obvious problem is the n+1. Problem here being that, let's say with our example of people by name, so we ask for Johns, and we get 100 Johns back, and then we want the Twitter profile of each of those. And then, as we saw what the hell is going on? I seriously don't know. So, as we saw, our resolver for Twitter profile will call Twitter API for this. So this would mean that if we 100 people to get the queries from, we'll hit this 100 times. So we don't want to be talking to Twitter 100 times, right? It makes no sense. So preferably, we want to get this all in one go somehow. Of course, it's possible. Otherwise, it would be kind of useless. So one way, it's enough to just annotate your resolver method with batched. And then instead of just accepting a single person, it will get a list of persons. And then, of course, instead of returning a single profile, it will return a list. The assumption here being that this API lets us batch our queries. If this was a call to some database or something, it would be trivial. You would just ask for 100 rows instead of for one row, and that's it. So this basically alleviates the load on your backend significantly. So instead of n+1, you just do, well, 1. The next interesting thing is optimizing fetching. So the thing here, so let's say we have our trusty people by name query that we already saw, and then our resolver for that. So sooner or later, there will be some query somewhere to fetch this. So if this is SQL storage, we'll do something like this. We'll select star from users where name is John, name coming from the parameter. But as you notice, this is kind of ugly. We don't need to fetch everything. We just want these two. But we don't have access to these two from within this method. So here, as it is right now, we can't do anything here. Well, turns out there's something we can do. So in the most simple example, we can simply inject the names of the required subfields. So these will be these. So now we can specifically say what we need to fetch from our storage. We just need those subfields. Now this is the very simple example. It's just a list of string, and it's just giving you the names of fields. But it's also possible to inject more complex structures. You can inject the entire tree, for example, representing all the fields with their subfields and so on if you need it. If you, for any reason, need to know subselections of subselections and so on. But point being, you can escape from select star. Now, authorization. So the way that now we assembled our logic, we have all these tiny little methods that are just in charge of tiny little thing. So we need to authorize the user on the level of a single resolver. Now, there's a couple of ways to do that, too. So one very obvious way, and that's universally available across any GraphQL implementation ever, would be to simply inject the security context into the resolver itself. So what this means, when you're executing a query, like here, so apart from the query, you can also provide any context object you need to provide. It can be whatever. So in our case, it would be the currently logged in user or his list of permissions or something like that. And then when you're executing it, you can get a hold of this object and then do any kind of logic you need to do, check roles or IDs matching or whatever you need to do. But it's really not nice, because then you have this logic and this thing in every single resolver ever, so you don't want that. So this is just in the context of a web application, specifically Spring web application. So you would get this user from the current Spring security context, for example, or something, and you would inject it like this. But it's much nicer to do this in AOP style. So there is nothing in the speaker library itself that will give you this AOP thing, but it will also not prevent you from using something else for that. So here I'm using Spring Security, so I'm just doing a very declarative Spring Security style AOP for authorization. I'll just say that this works if the user has a role admin, and then it's fine. So presumably you already have this code in place, you already have security in place. So what I'm trying to say here is that your security, normal security restraints will keep working. If there's something intercepting this call, applying some aspects, doing whatever, it will keep on working, all good. So there's a couple more topics that are somewhat related to this, but slightly different and still worth mentioning. One being that you saw how you can prevent a user from getting a hold of a field value they shouldn't, because you can protect the resolver method. But very frequently that's not enough, because maybe you don't want the user to even know this field exists in the schema at all. Maybe you want a whole chunk of schema invisible to certain class of users, for example. So this is a much harder topic, because first of all, it's kind of debated whether you should be doing this or not. There's arguments for both, and both are kind of valid, of course, as everything. So one way you can deal with this, perhaps, is to generate schemas for each individual user on the fly. It does not have to be super expensive, so if you can get it to be fast enough, you can of course cache that, but then that's its own can of worms, but you can do that. So for each user, as they make a request, you can regenerate the schema for them specifically based on their roles, based on their permissions. A somewhat similar topic is extensions, meaning that if you would have something like a multi-tenant application, then the different tenants might have the core of the schema the same, but then have their own custom extensions on top. So this is very related to schema visibility. You can basically say that one tenant should not be able to see, the schema of another. So same logic here. You can generate different schemas based on one schema extending another. So in Speaker itself, this is somewhat supported. So you can reuse all the types from one schema when defining another. So it will work. You can extend the schema. What you can't do right now is extend existing types. So if one schema already defined a type, extension schema will have a little bit hard time extending just that. But it's still something that you can do yourself maybe, and think about that. Now, caching with GraphQL is also a special topic on its own, because it's much more fine-grained than with REST. With REST, you would just have the entire URL, the entire request that that hit your endpoint, and just use that as key, and then everything that you returned can be cached, and that's it. With GraphQL, you can't do that, because you don't. Every time the request could be completely different, what the client needs. So, but in that hand, it's also much more powerful, because it's much more fine-grained. So you can get partially cached things and so on. So this is also like a pretty advanced topic to think of. And then, of course, there's a bunch of other things that I hope you will come up with to ask me. So that was it, actually. So this is me, and this is our site. If you just go here, it will send you back to GitHub. You will see our repository there with Speaker and what we do. There's a sample as well, showing you the stuff that I showed you. So a Spring application with everything wired and should be working, unlike for me now. But and yeah, after the talk, I'll be hanging out at ServiceNow booth if you want to talk to me about ServiceNow stuff. And now it's your cue. What would you like to know? You want that? Sure. Alrighty. So, anyone, anything? No? I did that amazing job that everything is super clear and no other problems coming up in your mind with this? Yay, somebody. Can we get a mic there? I can try it. I can surely try it. Yeah, that was kind of lame that it failed. Let me give it another go. Let's see what happens. Okay, I don't know why, but this time it worked. So yeah, so I just ran this. So I created another vendor. Oh yeah, interesting to see here, for example, when we're creating the vendor. So this is a mutation, so we say it's a mutation. I create a vendor, I give everything you need to the entire vendor object, and immediately select something back. So each mutation in GraphQL is immediately a query. So it's not like a 2 round trips to create something and then go again ask for it. So you immediately query back. So it gives us this new found guy. So he was created with ID 0, has the name that we given and so on. So I'll now try to do the same thing to fire a query against it. Pretty funny. Yeah, so similar thing. So I'm asking for the vendor with ID 0, that's the one we created, and I'm getting name, address, and stuff, and I'm getting that back. Now, to see, I'll show again in what happens in the backend. So this was what got fired. So for the creation, this is the method that executed. So we received deserialized normal Java vendor object. We created it in some way. We set it into our mock storage, put it and return it immediately so that the query can run against this. So this is the result that we're going to fetch the fields from. When I'm asking for the vendor by ID, this is the method that gets fired. So you see the annotation matching the query name. So yeah, vendor by ID here, vendor by ID here. So that's it. This was what got fired, and this was the code that wired it together. So a controller injecting this vendor service thing here, registering it here, and then exposing the entire thing with over this endpoint, GraphQL from annotation. So the query object that we sent gets immediately executed. The resulting object will contain data, resulting data, but also any errors that maybe happened. So if something happens, you can maybe get partial results. That's also possible. So the fields that were successfully resolved, you will receive. What's not resolved, you'll get nulls, and then you will also get an explanation what happened. So yeah, that was the entirety of the Java code needed to expose this thingy. So yeah, the presumption here is you already have these methods. So the idea is that it's usable in, like legacy code base or something. Yes, please.
How do you solve queries that have, like, for example, reference tables or anything like that? Is that still done in one query object, or how do you solve that? Because
you mean like in my example, you were fetching person and person had addresses and they live in a different table, you mean?
yeah, for example, but even with a reference table within. So, for example, you have a user that can have badges.
Yeah.
Badges need an action to get a badge, and you want to see the progress of every badge. So you need to get the actions, you need to get the badges, but also the count of the amount of action you did to see the progress of every badge. So, which means you have multiple joins in one query.
Yeah.
Is that also something possible within this? While still giving the user the freedom to query anything that they need, or how does that work?
Yes, it's possible. In that sense, so you don't change the way you do that because it's still your regular Java thing. So however you are doing it now, you can keep doing it. Now the thing to notice is that you can have here for example. Sorry, just to here. So you have like a rich object. So you can pass in any kinds of arguments that you need. So you can say, whatever you need to get the user, but then you said you want to drill deeper. So yes, of course, the way you would do it is with that context thingy that I showed with Twitter profiles and the thing. So you would say, for example, you would have one method just fetching the user, one just fetching the badges by the user ID, for example, another one fetching actions, what you said, by some other ID or something else. So you would do that by having 3 separate calls usually, and then connected by the context, so they would be embeddable. So you could still fetch deeply nested structure. You could still get user and then their actions and then their badges and whatever. So yeah, you can do that by connecting the resolvers by that context thingy. Yeah. So there's that. And of course, if you maybe needed to optimize this so that you want to prefetch maybe the entire structure because it lives in Mongo or something that has like structures that work that way, then you could do the other annotation that I showed that injects the selection. So it tells you what is selected even deeply. So you can maybe even save some round trips and not even do these 3 resolvers or whatever. Just do one big thing based on this. So this is possible. Yeah. Please. Yeah. You're far back, so I might need headphones to hear you.
Hi, great talk. I have a question. Do you have any experience with actually writing a Java client that connects to a GraphQL endpoint?
Kind of yes, but not really. But what I can tell you about it is not exactly pleasant because all the good clients for GraphQL are JavaScript. So that is amazingly solved problem. But if you want to be server-to-server communication, then Java is really not a happy language right now for that. You would basically be doing a lot of string manipulation and something ugly. But it is entirely possible to do similar thing that Java does with if you remember how we used to do things with WSDL. You just get the schema. This time, I mean, in GraphQL terms, it's a schema. In WSDL terms, it's the WSDL itself, the WSDL document. And you could easily generate a client from that already speaks the exact objects that your schema defines and has the exact methods corresponding to the queries and so on.
Yeah.
So it should be very easily doable, but it's simply nobody has done it yet.
Yeah, well, actually, for an Android project I'm currently working on, we are experimenting with the Apollo client.
Yes.
They are actually, but it's really like 0.1 or something. It's really alpha and under heavy development.
Yeah.
But yeah, they have an Android client for GraphQL. But I was thinking maybe you also did something like that.
Oh,
because
right.
I'm curious to see if that maybe had other advantages or not. But
right. So so I haven't done server-to-server GraphQL.
Okay.
I can see the value of that definitely, but yeah, haven't done it. I am aware of the Apollo thingy, and on at least the JavaScript library for it is absolutely beautiful.
Yeah.
It does everything right. For the Android, I'm really not up to date on what it does. I presume it's Android native version of their thing. They just compiled it probably using one of the thingies you can do these days.
It's actually a specific Java/Kotlin written new implementation of it. But yeah, as I said, it's quite new. So I was thinking maybe you knew of another, because as far as I know, it's the only Java GraphQL client in existence at the moment.
Right.
At least open source.
Yeah,
so,
right.
Yeah.
Well, in that regard, you're already ahead of me. I didn't even know that existed.
Well, but,
haven't done the server-to-server thingy. But yeah, good to know. But yeah, just thinking of the way it works, it should be like crazily easy to just generate a client, right?
Yeah, exactly. You have all the information to statically generate
exactly. Just do the opposite of
Yeah.
what I did just now. So instead of generating the schema from the client, generate the client from your Java code. So from the schema. So
yeah,
just do the
exactly.
opposite thing,
That's what happens there as well. Okay.
So it should be easy and yeah.
Okay.
But
thanks.
right now, I'm not aware of anything better than you already know.
In the tool that you show there behind, the GraphQL. In the tool you show there behind, the GraphQL, there is something like root types.
Yes.
So if you use the annotations on the methods, does it expose something versus the client so that it can discover what's available?
Yes,
kind
exactly.
of methods?
Yeah. That's exactly the idea. So I'll go back to graphical. So here you have 2 entry points into the graph because everything is represented as a graph. So it's like interconnected stuff. So the mutation root and the query root are the 2 entry points into the graph. So all of your top level queries and your top level mutations, well, all mutations are top level by the definition, but queries can be also nested. So all your top-level queries are actually just fields of the root type. And you don't need to do anything to advertise to the client what's available. The client will already know just by executing a special kind of query, like introspection query, that will basically ask the metadata on the schema itself. So it can already automatically discover all available queries, all available mutations, all the types that are known. It does. So GraphQL is actually doing this. At no point did I ever tell GraphQL what queries I have or anything. You just give it the endpoint to your GraphQL instance. That's it. It will figure everything else by itself. So these are all immediately discoverable automatically by the client. And this is actually the beautiful thing, because you no longer need anything special for your front-enders and your back-enders to document what one needs and what the other should make. Just by having a schema developed even first, if you can, everybody front-end exactly knows what they can get what they need, back-end needs exactly what to implement. So all of these, so you see here, for example, it automatically discovered this query. It says that it's returning a vendor. If you click vendor, it will know the type, what it has. So vendor has an address, and then address we can drill. And all of this is automatically discoverable.
Cool, thank you. Anyone else?